Okay, listen. Last class, what do you have seen? Last class. Last class, what you have seen? You have seen the general operations of JFET and VI characteristics of JFET. Okay, JFET is further normally FET is classified into three types. One is JFET. Okay, afterwards you can write. Listen, girls. JFET, Mosfet, Mosfet. Okay, three types are classified. Depends upon the constructions. Okay, already we know that JFET is something, but we will take one N-type bar. For example, we want to make N-type JFET means we have to take one N-type bar. In that, we have to add two P sides at the lateral sides of JFET. That is the construction for JFET. Okay. So depends upon the construction, FET is classified into three types. Okay. That is first one JFET, second one Mosfet, third one Mosfet. In your syllabus, they have given only JFET and Mosfet. Mostly Mosfet and Mosfet similar operation only. Little bit very slight difference only. Okay. So when we study Mosfet means it always represents Mosfet. Okay, both are same. Okay. What is the full form of Mosfet? Metal oxide semiconductor field effect transistor. Okay, that is the Mosfet. Okay, Mosfet is further classified into two types. One is depletion type, another one is enhancement type. Okay, in depletion type, further classified into two. One is N channel, another one is P channel. Why we classifying each FET into two means already we know that FET is a unipolar device. Okay, FET can conduct either by using electrons or holes. So depends upon the conducting carrier, we deriving a two structures for all the FET. Okay, but BJT we won't derive BJT for N channel and P channel because BJT can be conducted by using both holes and electrons. So we no need to find the two structures for BJT. But for FET, we have to consider two structures for each type of FET because whenever you want to conduct by using holes means we have to use what type? P channel. For example, we want to conduct by using electrons means we have to use N channel. So depends upon the requirement, we can use any one type of FET. Okay, both will be conducted by using their majority carriers. Okay, that is the two types, N channel and P channel. This is Mosfet. Okay, what is the advantages of FET? Last one, girls. What is the advantage of FET? When compared to BJT? என்னம்மா நோட்ல இருக்கும்ல? கேட்கல. நோட்ல இருக்குல்ல? இருக்கா? ஆப்சண்டா வந்தியா? ஆப்சண்டாலும் பரவாயில்ல, பக்கத்துல யார்கிட்ட நோட் வாங்கி பார்த்து சொல்லு. Temperature வேற any other required space கூட கூட்டம் say okay, already we know that BJT and FET are both are same applications, can be used for amplification. Okay, but BJT drawback is it is highly dependent on temperature. Another one is it requires more space for integrated circuits. When we deriving integrated circuit means it requires more space for BJT. So only we are moving from BJT to FET. Okay, FET requires very less space. FET is also dependent on temperature, but it is somewhat more stable than BJT. So only we move from FET. Okay, that is the FET. Already we know that JFET. JFET characteristics. JFET characteristics can be classified into two types. One is drain characteristics, another one is transfer characteristics. What is drain characteristics? The graph plotted between VDS versus ID is nothing but drain characteristics. Transfer characteristics is graph plotted between VGS versus ID. Okay, so we're going to plot the two graphs for studying the performance of FET. Okay, next we will move into the Mosfet. In Mosfet, first we will see about the depletion type of Mosfet. This is the different structure when compared to JFET. Already we know that JFET structure is like a PN junction diode. Okay, but MOSFET is a completely different structure. We will have to take a one P-type substrate. In P-type substrate, we will have three terminals: source, gate, drain. Okay. In JFET, what is the condition of gate terminal? Gate should be JFET la gate எப்படி இருக்கும்? Gate. In JFET construction, gate is directly connected to the substrate. Okay, there is no separation between gate and substrate. Okay, in JFET, all the terminals will be directly connected to the substrate, either P type or N type. But when you see this diagram, MOSFET, there will be a separate layer. This is insulating material made up of SiO2, silicon dioxide. Okay, there will be a separate layer between gate terminal and substrate. That is the difference between JFET and MOSFET. Remaining under same. Okay, little bit construction only vary. Okay, but the gate is most important because gate is isolated entirely from the substrate. Okay, அது பார்த்தாலே தெரியுதுல, gate க்கு எந்த கனெக்ஷனுமே கிடையாது. Okay, when we see the other two terminals, source will have connection to the substrate, drain will also have a connection to the substrate. Okay, due to this reason, MOSFET will provide high input resistance. When compared to JFET. Okay, this is the advantage of MOSFET. Okay, because JFET will have all the terminals will directly connect to the substrate, so it will have offer some low level input resistance. But MOSFET gate is completely isolated from the substrate, so it will provide a more high input impedance. That is the advantage of MOSFET. Remaining and all same thing. We have to add two N-type material with the P substrate. Okay, it will provide a one channel like structure, so it is called N channel MOSFET. Okay, N channel depletion type MOSFET. Okay வா, நம்ம எதுக்கு நேம் வச்சோம் சேனல்னு? ஒரு பாத் மாதிரி கிரியேட் ஆகும். ஸோ அந்த பாத்தை கன்சிடர் பண்ணா சேனல் நேம் வச்சோம். சேம் this will provide a channel like structure, so it is a N channel depletion type MOSFET. Remaining and all same. In JFET, we will have two gate terminals. Okay, we have to short the Anjana. We have to short the two gate terminals into single one. But in MOSFET, we will have a two sides. One is this is source, another one is substrate. Okay, we have to short this substrate with the source always. Here I did this. This substrate is directly connected to the source. Okay, but in JFET, we have to connect the two gate terminal into single one. That is the slight difference between JFET and MOSFET. Okay, the remaining and all same operation. What is the basic principle of FET? What is the basic principle of FET? VGS is the important thing which decides the ID. Okay, we are going to take the readings between two VDS and ID. Okay, Suppose VGS equal to 0 means the channel will be very free, so electron will move from source to drain. Whenever electron is moved from source to drain, it will constitute a drain current. So automatically ID will be I when VDS is I. After that, suppose I am going to increase VGS into negative bias means what will happen? The depletion region will get formed. The depletion region will uh, close the path which between the source and drain. So automatically the electron flow will get reduced. So ID will be get reduced. This is the basic principle. Same principle here we are going to use. Same thing. Okay. அங்க என்ன இருந்துச்சுன்னா ஒரு ஸ்ட்ரக்சர் டிஃபரெண்டா தான் இருந்துச்சு. இங்க ஸ்ட்ரக்சர் எல்லாமே வேற, ஆனா கான்செப்ட் ஒன்று தான். ஓகேவா? தட் இஸ் தி பேசிக் கான்செப்ட். Here I am going to connect G with S. Already I told that S is always connected to the substrate. Here I am going to connect D with this S. This is VDD or VDS. Okay. Initially I am going to apply VGS equal to 0. Okay. VGS equal to 0 means what type of bias? Forward or reverse? VGS is the controlling voltage which controls the flow of drain current. I am going to apply VGS equal to 0. So there is no problem for this channel. Okay, wa? So the channel will get free. So automatically the N type will have more electrons. That more electrons will move towards drain, which will constitute drain current. So at initial VGS equal to 0 means electron will freely move from this place to this place. So drain current will be more. This is the first point. Second one, I am going to reverse bias, which means I am going to provide negative bias. Automatically negative bias means reverse bias. What is the depletion region condition in reverse bias? Depletion region reverse bias எப்படி இருக்கும்? Widen. So automatically this P type, this N type electrons will combine with each other. So there will be a depletion region will be formed. Okay, in this case automatically the path between source and drain gets awfully closed by the depletion region. So the amount of electron flow from source to drain will get somewhat reduced. Okay, that is the second case. Okay, first எப்படி இருந்துச்சு, அந்த சேனல் வந்து ஃபுல்லா ஃப்ரீயா இருந்துச்சு. ஸோ சோர்ஸ்ல இருந்து ட்ரெயினுக்கு எலக்ட்ரான் ஈஸியா மூவ் ஆச்சு, நம்மளுக்கு ட்ரெயின் கரண்ட் அதிகமாக வந்துச்சு. செகண்ட் பாயிண்ட்ல நான் VGS ஓட வேல்யூவை கொஞ்சம் அதிகப்படுத்துறேன் நெகட்டிவ்ல. So depletion region will get created. It will occupy the channel between source and drain. So automatically the electron flow will get reduced. This is the second case. Third one, I am going to further increase the negative bias. Okay, automatically the depletion region will get widened. Totally it will occupy the entire channel between source and drain. At this point the drain current will get 0. Okay, why we get drain current 0 means there is no path between source and drain. So there is no possibility of flow of electrons. So ID current will get 0. Okay, what name this is? இந்த condition பேர் என்ன? இந்த condition பேர் என்ன? The point at which ID current gets 0, that is cutoff voltage, otherwise cutoff region. Okay, this is cutoff voltage. Okay, this is third one. After that fully the entire depletion region gets blocked. So I am going to increase the VDD further. Okay, at one point the total entire depletion region will get breakdown. So the flow of electrons will be more. So the flow of electrons from source to drain will get suddenly increase. It is called என்னது? நான் ஏற்கனவே சொன்னதான் திரும்ப சொல்றேன். ஓகேவா? பிளாக் ஆகி எல்லாமே பிரேக் ஆயிடுச்சு. இப்போ என்ன ஆகும்? N type of electrons enormously cross the source to drain. It will cause enormous amount of drain current. That is breakdown region. Okay, okay. After that, that is breakdown region. Okay, totally entire depletion region gets break. So more amount of electron will flow. It will cause more amount of current. That is breakdown region. So this is the two characteristics. One is drain characteristics. Another one is transfer characteristics. Same thing. Same like structure of JFET. Okay, JFET drain characteristics will have six regions. What are they? First one is VGS and VDS equal to 0. That is this point, region number 1. Okay, VGS equal to 0, VDS is also equal to 0 means there is no amount of ID current, drain current. So origin point is the first one. Second one, I'm going to not increasing the VGS. In this region, VGS will be considered as 0. Just I'm going to increase the VDS. Whenever I'm increasing the VDS, automatically the drain current will get increased. So we'll get the graph this. That is the second one. Okay. Third region is VGS equal to negative. Whenever I am going to make VGS as negative, the depletion region gets formed, which blocks the path channel between source and drain. So amount of drain current will get reduced. So after this point, it will get constant. That is the third region. Okay, this is pinch off voltage, the point at which ID current becomes constant. ஓகேவா? இது வரைக்கும் நம்மளுக்கு எப்படி இருந்தது? எக்ஸ்போனென்ஷியலா இன்க்ரீஸ் ஆச்சு. இந்த பாயிண்ட்க்கு அப்புறம் it becomes constant. The point drain current becomes constant. That is called pinch off voltage. Okay. After this is saturation region. Okay, after saturation region, you will have breakdown region in JFET. But in Mosfet, practically there is no breakdown region in Mosfet. Okay, but நடக்கும் எல்லா டிவைஸ்மே என்ன ஆகும்? uh, VGS equal to ID equal to, we have to point 2 point. First one, we have to make ID equal to 0. We will get the maximum VGS. That is this point. After this, we have to mark this point. For this, VGS equal to 0, ID should be maximum. When we join the 2 points, we will get the characteristics that is called transfer characteristics. Okay, this characteristics is plotted between VGS and ID. Okay, wa? Now, okay, listen. Okay. Next, we will see the enhancement type. Okay. A slight difference. Same operations. JFET, MOS, depletion type, enhancement type, all they have same operation. Okay, listen. 2 minutes. The basic major difference between enhancement and depletion type is there is no channel between source and drain. Okay. In depletion type, we will have a one channel between source and drain for movement of electrons from source to drain. Okay. Through the channel only, drain current will get generated in the depletion type. But in enhancement type, there is no channel between source and drain. Okay. So it will assume as a channel, virtual channel between source and drain. Okay. Last diagram க்கு இதுக்கு என்ன difference? Last diagram ஓட channel எப்படி இருந்தது? Channel is a perfect shape, perfect channel like structure. But here it is like a not uniform channel like structure. It is a improper channel like structure. The reason is the channel here is virtual. It is a imaginary channel between source and drain. So it won't be a perfect channel like structure. It will be a like improper channel like structure. So only the channel width is here is more, here is very less. Through this channel, the source electron will move from source to drain. Automatically, the current will get generated. Okay, after I am applying VGS equal to negative, automatically the depletion region will get formed. It will block the channel path between source and drain, so the drain current will get reduced. Okay, same operation. Slight difference is there is no channel between source and drain, so here it will assume a imaginary channel between source and drain. Imaginary channel will be a not a perfect shape. It will be blocked by the depletion region. Okay, so automatically drain current will get reduced whenever VG is equal to more negative. Same graph, drain characteristics, transfer characteristics. Okay, wow. So drain characteristics of FET. First point, VGS equal to VDS equal to 0. First region, VGS equal to VDS equal to 0. When VGS equal to 0, the channel is entirely open. When VGS equal to 0, the channel is entirely open, but VDS equal to 0, there is no flow of electrons. There is no flow of electrons, and hence drain current does not flow. And hence drain current does not flow. Second one, self pinch off at no bias. Second, self pinch off at no bias. At VGS equal to 0, in response to small applied voltage VDS. At VGS equal to 0, in response to a small applied voltage VDS, the current ID increases linearly with VDS. The current ID increases linearly with VDS. As VDS increases, the voltage drop along the channel also increases. The voltage drop along the channel also increases. This increase in voltage increases the reverse bias on gate source junction. Increases the reverse bias on gate source junction, which makes depletion region to grow. GROW, grow. When the channel width get reduced, the channel width get reduced, the drain current, the channel width get reduced, the drain current also gets reduced. Okay, next point, at some value of VDS, ID cannot increase further. At some value of VDS, ID cannot increase further. due to reduction in channel width. Due to reduction in channel width, any further increase in VDS, any further increase in VDS does not increase the drain current. Any further increase in VDS does not increase the drain current. So it approaches the constant saturation value. So it approaches the constant saturation value. The voltage at which ID reaches its constant value, the voltage at which ID reaches its constant value is called pinch off voltage. Is called pinch off voltage. Third point, fourth, VGS with negative bias. VGS with negative bias. When an external bias negative voltage, when an external bias negative voltage is applied between gate and source, the gate channel junctions are further reverse bias. The gate channel junctions are further reverse bias, reducing the width of the channel. Available for the conduction. Because of this, drain current will reduce. And pinch off voltage is reached at lower drain current. Next one, breakdown region. If we increase VDS, the drain current remains constant. If we further increase the VDS, the voltage will be reached at gate channel junction. Breaks down. Gate channel junction breaks down due to avalanche effect. At this point, the drain current increases very rapidly. At this point, the drain current increases very rapidly and the device may be destroyed. And the device may be destroyed. Okay, next one, ohmic and saturation region. Ohmic and saturation region. In ohmic region, ID varies with the ID varies with VDS and the JFET to be resistance, variable resistance. In saturation region, the ID remains constant and does not vary with VDS. Does not vary with VDS. To use FET as an amplifier, it is operated in this saturation region. It is operated in this saturation region. Next one, cutoff region. As we know for N channel JFET, the more negative VGS causes drain current to reduce. The more negative VGS causes drain current to reduce and pinch off voltage to reach at lower drain current. Pinch off voltage to reach at lower drain current. When VGS is made sufficiently negative, ID is reduced to 0. This is called cutoff voltage. This is called cutoff voltage.